Okay, so today what we're going to talk about is something of the linear form. It is called direct variation. So direct variation is a linear function or a linear graph in the form y equals kx. Now this is all from should be pretty basic, but if you can notice the green, the blue, and the red line, they all have something in common, and that very important thing is they go through the origin. So one thing you can think of is that the y-intercept of these lines are 0, 0. So all direct variation equations will have graphs that are linear, and they will always go through the origin. So I just wanted to show this to you, make sure you're aware of it. Really, really, really simple. Now, a couple examples. Does the equation 6x plus 3y equals 9 represent a direct variation? If so, find the constant. And then what about 4y equals 3x? So when you're doing this, you have to think about direct variation is y equals kx. Okay, where k is your constant of variation. In this case, we have something in standard form. So what I'm going to do is I'm going to take 6x plus 3y equals 9, and I'm going to solve this thing for y. So I subtract 6x. All right, now I can't take that 6 from that 9, so it's 3y equals negative 6x plus 9. And then I'm going to divide everything by 3, right? Okay, so then you get y equals negative 2x plus 3. That is a linear form, but that is not y equals kx. That's y equals mx plus b. So this is not a direct variation. Okay? Let's check out the other one, 4y equals 3x. With this one, again, we're thinking about y equals kx. That is what we want. So in this case, we're going to solve this cowboy for the letter y. So all we're going to simply do is go ahead and divide both sides by 4. So you get this. And your slope, also known as your constant of variation, is in fact 3/4. Okay? Pretty simple. All right, moving on. When you have tables, okay, when you have tables, are either one of these tables direct variation? You can't just say yes or no, you have to think about it. So what we're going to do is know that direct variation is equal to y equals kx, okay, where your constant of variation is y divided by x. So what you can do here is you can actually take the first point, 15 divided by 5, you get 3. Then you do 18 divided by 6, you get 3 again. 21 divided by 7, you get 3. And then 24 divided by 8, you get 3. You can see that all four of those are from, all four of those are, have a constant of 3. So yes. And in fact, it is y equals 3x. Okay, let's check out this other one. This one right here, if you take 4 over 0, that's undefined. Then you take 10 over 4, that's 5 halves. And then you take 19 over 10, which is 19 over 10. This is not direct variation. Okay, it's not. It is not direct variation. Very simple. All right. Now, when you are doing direct variation, a lot of times there is story problems that go along with this stuff. So, key words in story problems are varies directly or directly proportional. So if you have those words, then that indicates y equals kx. So when I read this, the time it takes you to hear thunder varies directly with your distance from the lightning. If you're 2 miles from where lightning strikes, you will hear thunder about 10 seconds after you see lightning. Write an equation for the relationship between time and distance. About how far are you from lightning if you hear thunder 7 seconds after seeing lightning? Now, I underlined varies directly, so I have to be thinking about y equals kx, and that my constant is y divided by x. Now, time it takes you to hear thunder varies directly with your distance. So really, time is the y, so t equals kd if you want to talk about that. So t equals kd. In this case, if you are 2 miles from where lightning strikes, you'll hear about 10 seconds. Hold on, wait, I think I goofed that up. Give me one moment. Nope, 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 nope. I'm good. So if you look at this, you have time. Which one of these involves time? If you are 2 miles from where lightning strikes, you will hear thunder about 10 seconds. Well, the 10 goes in for time, and then 2 goes in for the distance. So now you have 10 equals 2k. So you divide both sides by 10. So, excuse me, nope, you divide two sides by 2. You get 5 equals k. That's your constant of variation. That is, it is 5 seconds per 1 mile, if you want to think of it that way. So your equation is time equals 5 times d. Now the second part says, about how far are you from lightning if you hear thunder 7 seconds after seeing lightning? So what you're going to do is you're going to put in 7 right here, and you're going to go 5 times d, and then you divide both sides by 5. So d is 1.4 miles. You're 1.4 miles away from the lightning, if or from the storm, if you saw the lightning 7 seconds after you heard thunder. So it's pretty simple, pretty easy. It takes a little bit of practice, but I promise you it's nothing you can't handle. So hopefully this video helps. Please do the guided notes, and I look forward to seeing you in class um, tomorrow. So have a nice day, and may the force be with you.